I'm just going to start with a brief overview of just some slides of some of the things that we did in the field that were a little bit different than what's been done in the past. And then all the experts up front are going to answer your questions. I do have a microphone that I'm going to run around to each of you, so please wait to ask your question until you have the microphone, and then our speakers in the front will have their microphones. So hopefully everyone will be heard this time. Apparently the first session was not very well recorded. I apologize for that. So to begin with, one of the first innovative strategies that we had to come up with for this project was to build the boardwalk at Sagelot Pond, which was the primary site for the study. We had both high marsh and low marsh data collection that had to take place, so we needed to create something that the researchers could get around on without distorting the gases that they were trying to measure, but also try to reduce our impact on the marsh that we were trying to study. In addition to that, we had both vertical and lateral flux measurements were recorded using analyzers. They were laser-based absorption technology, and the two models that were used were the Picaro, which took real-time data for carbon dioxide and methane, and then the LGR, the Los Gatos Research Analyzer, which took data of nitrous oxide and carbon monoxide. This is a slide that Serena graciously provided for me, just showing the difference in how much better resolution we were getting with the new analyzers in the field. Notice on the left side, those discrete samples, just not quite as much data points as we were able to get with the new technology. So that was really key to the data collection. Of course, we measured the slope in these lines to figure out the flux. So for vertical flux, in addition to the analyzers, they needed to be connected to a flux chamber that was sealed to the marsh. There was 2 by 2 foot plexiglass chamber that went down on a collar, metal collar that was sort of dug into the marsh to create a really good seal with the sediment. And then those measurements took place for about 5 to 10 minutes in the gas chamber, and then the real-time data collection from the analyzers was possible. For lateral flux, they had a kind of more complex system, which if you have questions about, you should really ask Kevin, because I can't do it justice. But this was their setup at the Sagelot Pond site. Notice all the scaffolding and computers and all sorts of interesting fun things. They also had to come up with sort of an on-the-roads option for the other nitrogen sites, which involved getting all of the equipment into some sort of vehicle and then having many, many 100 feet of tubing in order to get down to the creek edge where the tidal flux was happening in the channel. So there was a lot of innovative work done there, things to help elevate everything so that it wouldn't get flooded during the high tide and things like that. And then finally, the coring that Meagan did, which she talked about a little bit this morning with the piston corer, also pretty interesting technique to try to reduce the amount of compaction in the core and also give us some really great data over a really long-term basis. So those are some of the interesting things that we got to play with in the field. I'm just going to bring up a picture of the Sagelot site to give a little bit more of a idea of our sort of design in the marsh. So this is Sagelot Pond again. This is our primary site with the boardwalk. You can see the boardwalk comes out from the upland and then goes down to the low marsh and kind of tees in the low marsh. We had 9 vertical flux collars in the low marsh and 9 in the high marsh. And then right sort of the first creek that you crossed after the T in the boardwalk was where we took our lateral flux measurements. So this is just to give you a better sort of conceptual idea of where these data points were taken, where they were in proximity to one another, and also just background information. The habitat map that's the background for this image is based on a 2004 survey. So the habitat zones have shifted a little bit over time. Also, the other monitoring parameters that are on this map, including the vegetation plots and the surface elevation tables, are part of a long-term Sentinel site initiative begun with the National Ocean Research Reserve System. So there's that ongoing research within the site as well. And with that, I'm gonna open it up for questions to our experts, Serena, Meagan, Kevin, and Jim Tang.
Hi, Jim. So you must know, having asked that question, that that's part of a proposal that's planned. The existing efforts that I'm personally involved in are simply helping to test some of the climate adaptation strategies that rental construction, for example, to drain the marshes, and it's just asking the question of whether the carbon exchange responds. Is it resilient in some way to that intervention? But beyond that, it certainly is a research need to figure out how these functions change as the location of the marsh itself shifts, along with the composition of the communities.
Are you interested in the question of carbon sequestration in the coastal forest versus salt marsh that might invade that forest? Is that one of the questions? Yeah. It's a really good question, and I think something that is of interest for sure. I had a conversation yesterday with someone who mentioned a couple of projects down in the Chesapeake area. I think it was someone named Glenn Gutensberg, I think, at the USGS, who where they are experimentally flooding some coastal forests and looking at change in the soil behavior in terms of carbon with that kind of events.
Hi, this is actually for Kevin. It's kind of a question I had from yesterday. In your data, you had showed carbon-13, and there was one kind of outlier where there was a kind of big dumping of terrestrial material, and I was just wondering what caused that, and if it was an intense precipitation event, and or if it was something else, and the role that kind of increasing intense precipitation events could have on kind of these lateral fluxes.
Mm-hmm. Yeah, we in terms of actual physical sample collections with isotope analysis, we only captured that kind of event once. But when we look at our longer-term record of salinity, we see that they're fairly frequent, pretty intense freshening events that occur. So I think mostly that has to do with the relative sea level and aquifer hydraulic heads. And you can see that when sea level, not just on a tidal time scale, but there's somewhat, lunar cycles and somewhat longer cycles where the sea level drops kind of across the baseline, not just the low tides being low. Then you do get these freshening events, and there's quite a lot of DOC and DIC as well in that groundwater. That particular watershed at Sagelot Pond is pretty high level of carbon supply to the aquifer. It has a very productive forest with a deep litter layer, and the unsaturated soil thickness above the aquifer is very thin, and so there is a relationship between that unsaturated soil thickness layer and the amount of organic matter that makes its way into the aquifer, and so it's a source for sure, and So I think it mostly has to do with sea level more than with rainfall.
Actually, I have a question for Meagan while we're here. So you had mentioned that there's kind of a peak elevation where the marsh seems to be doing pretty well in terms of keeping up with sea level rise, that being sort of in the low marsh zone, and that the high marsh will shift to low marsh vegetation and hopefully also be able to keep up. But at Sage Lot, and I think sort of in the southern New England area, we're seeing these pool developments, which makes me fearful that maybe it's not switching to low marsh. And I was wondering if you could speak to that at all in terms of what that might mean for our accumulation rates.
You mean the pan development, right? Yeah. So I didn't look at any carbon accumulation rates in the pans at Sage Lot Pond, but I did. Amanda Spivak, who's a researcher at WHOI, has been doing coring up at the Plum Island pan sites and looking at accumulation rates and carbon storage there, and the accumulation rates are extremely small in the pans. They're not, it's tough to see if the accumulation rates are just teeny or if there's just erosional events, but I think there's actually probably both. And it does look like carbon is burning off from those because they're, through the water, they're in direct connection with the atmosphere. And so if you start converting large amounts of your marsh to pan and it can't, the grasses can't populate, then that would obviously have a detrimental impact on both marsh survival and carbon storage.
Speaking of the pans, I just wanted to ask a relevant question. If you know if there is a significant difference in drainage rates for newly formed pans and the old pans, which are say 10 years old.
Yeah, that's a good question. I don't have any information on that, but and it's not a question I've looked into, so I don't know whether anybody has tried to determine that. There are clear differences. You can see some pans, they fill up when the tide is very high, and that water doesn't appear to drain. It just stays at the high level. But there are other ones that seem to drain pretty quickly. So I would think that as they age, there would be deposition of very fine material on the floor that would impede drainage.
This is actually a question which I'm trying to address, and I wonder if anybody else has studied that.
I don't know.
Not that I know of.
Yeah.
This is kind of something off topic, but I think has application here. Has anyone looked into kind of pollution or specifically organic pollutants and whether these marshes are able to retain reactive organic pollutants, be it legacy or emerging contaminants, or is that a new realm that hasn't been kind of investigated yet?
What pollution? Can you say it again?
So one of the benefits of organic matter is that they can obtain persistent organic pollutants or other reactive organics. And so I'm just wondering if any work has been done to look at the retention of harmful organic pollutants, whether they're anthropogenic, such as larger polycyclic aromatic hydrocarbons or other such. Is that something that hasn't yet been investigated, or is it room for kind of input here, or is that something completely off topic for blue carbon?
Yeah, I don't know anything about it, but it's an area that I'm super interested in, and not just for the salt marshes, but also for the permeable sediments in Wacoit Bay, because they're essentially filtering our groundwater, which is essentially our sewage system. And so there's a lot, but nobody's really looking at it. So if you're interested, I'd love to talk about that.
Yeah, I'd love to talk
We
about
haven't looked at those things, but I'm thinking about the nitrogen deposition. You think about the pollution, it's one of the pollution, but in our Wacoit Bay, it's just small area. We don't see any difference. But in the future, we are thinking about doing some study of the similar study across New England and beyond. then I think the nitrogen deposition rate may become the factor. In addition to all the nitrogen loading from the groundwater, there's a deposition from the air. That might be taken into consideration when you think about nitrogen storage across a larger area.
For me, it's going to be for you. It's about the course.
So just because it's a relatively quiet time, I thought, I was just in the modeling thing with Omar. And one of the things I've been thinking about is that water, the water depth or depth relative to elevation of the site relative to water depth. And thinking that how best, or thinking how best to really, I mean, what would we really be after? Really what we want to know is kind of how, I mean, there's sort of the instantaneous thing, where is your water level at the time that you're actually making a measurement and you have an absolute elevation of your site. At that moment, you have an instantaneous number relative to water depth going on. But what you really want is how often that location that you're measuring is being inundated, for two things. How recently, in terms of where are you relative to the last time it got flooded in time. And also, not so much absolute depth, but it's the depth relative to range in the sense of how much time, where do you sit in that thing? How much time does your, say, mean high water go over that location? So really, from a more average sense, and in terms of being able to collect data, for managers, a more simple thing would be to get a mean high water value and get a tidal range value and get an elevation value. From that, you could basically have a number that relates to its inundation value. And that might actually show up as, I keep thinking that could show up as more important. I'm not sure how different it would be than soil moisture. Getting at soil moisture might be a way to just get at it straight, which we already record. But I'm wondering if that other number might be a more useful and show up as a more significant number if we look at it that way. It'd be more static, but it might be more helpful.
Right. No, it's an interesting idea, and so we can produce maps of the site that show things like percent of the time that particular location is inundated. And Neil Ganju, who's part of the USGS team, he produced a map like that for the Sage Lot site, and that was, I think it was based on the LiDAR data rather than the elevations that Jordan measured, which may be a little bit different. It may be better to base it on the locally measured data. But yeah, so that's a good thought. That can be done with the levels measured in the creek, the water levels measured in the creek over time relative to those elevations. But something Meagan and I have been talking about is, in the context of the new project, is we're talking about how to monitor water level in those sites. And we're thinking of wells with loggers in them will be maybe more useful information, because what the soils actually experience is the water level in the pore water, which may be a little bit different than what's in the creek and the flooding of the marsh. So for instance, there's going to be a significant lag when the water level drops in the creek. Then the pore water is going to slowly drain, but it's going to be above what that low water is. So yeah, I think a long-term record on from a well in the peat might be the most useful. I don't know if you would agree, but that's...
Yeah, I mean, they probably all get a similar thing. I think that's the kind of thing that would have to be kind of almost calibrated, because it's what's really doing the work. If you have a number, it just shows the inundation time. Obviously, it's going to relate to how fast that's draining down. And even the temporal variability over time. But if you're looking at the, developing models that managers can use, they probably want to get off-the-shelf numbers as rapidly as possible for doing large areas. So like a mean sea level for the area, something like that. But if you could get some sense, average sense of drain time, or if you have water over top of it, how much time does it take to go through, and how does that affect it? Does that vary much marsh per marsh, or in either organic rich soils or mineral rich things? Is there a great difference in porosity? Maybe that's important. Soil type. So those would be factors, I think, to work in. But I was interested to see that the value of water depth was, in terms of this relative water depth, is not really high in the model, although it's useful for methane. But I thought maybe but the way we calculate it maybe could be better, in some sort of average sense.
Yeah,
Calculate that relative water.
I think in the model it is the most important parameter for methane, and so I think you make a good point that although what the water level in the soil at that particular location is really what's most relevant for application of a generalized model, you want some data that's going to be readily available. So that would be local sea level, which means we have to measure both, and then right in the next project, I think.
I just want to add that in some of these marshes, for example, mean sea level and lower water do not have any physical meaning, because the marsh itself is at high elevation and its level is above, cannot drop below the seal, which separates the marsh from, say, open ocean or bay. So in some of these marshes, you can only determine high water or mean high water tidal datums, but mean sea level and low tidal, low water are not, cannot be defined. I mean, you can measure them, but they don't have physical significance because they're not dynamically related to what's going on in outer bodies, outer water bodies.
I just want to follow up a little bit on the groundwater wells, because we do have this long-term monitoring in place. I've struggled a little bit with what depth is best for the groundwater well, and I was wondering if you guys, if I have a data logger out at the marsh that I hope to, keep deployed sort of in the long term, at least when it's not ice, what depth do you recommend for salinity or just groundwater level for a site like Sage Lot?
Yeah, we've talked about that a little bit recently too. Sage Lot would be a little bit easier than the North Shore Cape Cod, where the tide range is so much larger. So I think something that's screened below the lowest sea level you think will occur would be most useful. Then your well isn't going to go dry at any time. It may not anyway. Probably, maybe it doesn't have to be below the lowest, but below typical low tide, probably be most useful, because you do want it to be near the top and the most biologically active part of the soil as well, if you're going to be measuring things like salinity and other chemical parameters. But you want it to be deep enough that it's going to give you that continuous record of level.
So would you almost recommend deploying two, kind of like either within the same well or right next to each other, one that's like within the top 20 centimeters and then one that's like a meter or two down?
If I answer yes to that, then you're going to want to take your loggers back that we borrowed.
I might have a couple spares still.
I think that might be useful to do, but I think it would get expensive and that much more labor intensive to do, especially if you're trying to cover a lot of space. Maybe at Sage Lot, if you're doing that just
like
one
one
sentinel
spot.
site, might be interesting, yeah.
Thanks.
Yeah.
I would love to hear a little bit about where future research is going for you guys. I know I've missed out on some of the meetings that I think have happened on sort of next moves and proposals and things like that, but I'd love to hear a little bit more about what you guys are planning to do at Sage Lot or on Cape Cod or wherever.
I'd like to hear from Serena on that. I know what we're doing, but I don't know what you're doing in this.
Okay, go ahead.
Let's see. Well, I have several projects wrapping up, actually. This one being one of them. And so one of the things that I am finishing next is a study of how subtidal invertebrate shellfish influences greenhouse gas production, nitrous oxide, and I've been testing that under nitrogen enrichment and warming levels with a graduate student of mine, Melanie Garate. We're also beginning our first studies in mangrove forests in Puerto Rico with funding that she has received from the Nature Conservancy that's starting this summer. And she's doing a relatively short-term nitrogen enrichment experiment in the mangrove forest and looking at how fiddler crabs also affect the greenhouse gas emissions. And I'm starting what I hope will be a long-term data series measuring responses to one of the local restorations in Rhode Island where they're starting experimental runnel additions to marshes in an attempt to help facilitate drainage of standing water on the marsh surface. So dealing with some of the high marsh loss, testing whether the net ecosystem carbon balance can be restored.
Wow, mangrove. That is the first time I heard from you. For next, I think a following project. This project is almost ending, and we found a lot of new questions. We haven't answered that, and then we'll continue to answer some questions. One of them is how the results or information generated from this project can be generalized to a larger area in New England and beyond. So particularly on the different range of salinity and the different range of higher range of nitrogen loading and what happened to the greenhouse gas fluxes and the carbon storage in soil marsh, including lateral fluxes and the vertical fluxes. So to do that, including lateral range, basically larger range. So to do that, we now try to do something across a bigger range of the area and do some of the measurement to verify the model that Omar and his group developed to see if the model can be used by the different conditions, including latitude and nitrogen range and temperature and salinity range. So that is one of the next direction to see. So those information or large range of information will help us to really understand some of the engineering projects such as restoration. So we hope to use those generalized information to really help us evaluate some of the coastal restoration and conservation project. For example, in Herring River, people will restore some of the soil marsh, large area of soil marsh. So we want to evaluate how those restoration help us to sequester more carbon. But to do that, use the current knowledge is not enough because the restoration project involved a large range of salinity change to drive the greenhouse gas, gas flux and lateral flux. That is more than current our project can do, so that we have to go there to make more measurement and generate more kind of robust model to help us understand. So that is one of the things I just summarized. The other thing is my own group is doing is one of the factor, temperature. We haven't really not been focused much. So that we try to use some of the temperature manipulation experiment, basically to mimic increasing temperature. And we want to see how that greenhouse gas respond to change in temperature. Actually, Kevin and I, we do together to see how we can respond to the change in temperature. So that is a kind of extending project for this current BWM project.
That pretty well covered it, I think.
Great, thanks for that. Are there any more questions from audience? All right. Well, I think we have about 10 minutes or so before the next presentations and things are going to start up. So it's a good point for a break and grab some more coffee. Thanks so much, guys.
Thank you. Thank you all.